Ding. Today, it looks like we only have one section to cover. We're going to cover section 4.2, which is on page 235 if you need to know that. Page 235. And this section is on polynomial multiplication. Polynomial multiplication. And our first example we're going to start with is number 1. So we're going to start at the bottom and work our way to the top. This would be the most basic polynomial multiplication you could do. This is a monomial times a monomial. Y'all see that? One term times one term. Yeah.
Wouldn't it off the bat, wouldn't it end up being y to the third power?
Yeah. Yeah. Because when you multiply letters, you add their powers, and the second y has an understood power of 1. So this is a two-step process. First, you need to multiply the coefficients. 8 times 3. And then if the letters are the same, add their powers. And that is done. Did y'all hear the two steps involved? Multiply the coefficients. If the letters are the same, add their powers. Got that? Now, if you understand those two steps, you can do...
What if it would have been like 8y to the second times 3x?
Okay. We'll play the what if game. What if? Say it again, Ariel.
Let's say we keep the same numbers, just y on the 3 becomes an x.
Okay, so 8y to the second, and you said, what if that y was an x?
Yeah, because you said if they're the same, you can add them.
Right.
But they're not the same.
Right. So you're still going to start with multiply the coefficients. 8 times 3, 24. But if they have different variables, what you're going to have to do is you're just going to have to write those variables in alphabetical order. So I have an x and a y squared. If the letters are not the same, you're just going to write them in alphabetical order. Okay?
We will get those, right?
Oh, yeah. Oh, yeah. Any other questions before I do another one? Everybody knows the word coefficient means the number in front of the letter.
Will we ever get 3 terms?
Oh, yeah. It's coming. Yeah, you're excited, I can tell. Number 7. So this would be a step up. Here, this is a monomial times a binomial. One term times two terms. And this is affectionately known as the distributive property.
Would it be 14z minus 2z equal xz?
So first, 2 times 7. And there is a variable. Say it again. Right. Because when there's multiple terms, you have to do them each separately. So the 2z times 7 is going to give me 14z. And then the 2z times negative x is going to give me another term.
And you have to put them in the same first order?
Alphabetical order, yeah, would be nice. It's not necessary, but it makes me happy, okay?
So it would be 2x.
It would be negative 2xz. If you want to be perfect, negative 2xz. Negative 2zx would be acceptable. Anybody have any questions on a monomial times a binomial? Okay, we're going to step it up a notch. Now this is my first problem. I'm going to make one up. Let's do 3xy squared times negative 2x squared plus 5xy minus 10. Okay, now, does everybody notice that this is a monomial times a trinomial? This is all one term. It's got three factors, but it's all one term. This is a term, this is a term, and this is a term, okay? So again, we're going to do the distributive property. And what you need to do, think of this as three little problems instead of one big problem. It's really three little problems. Ariel?
Can I get a try it?
Huh?
Can I get a try it? I think I want to see if I'm actually doing it right or am I?
Okay, so when I write it down, you can check and see if it's right. That'd be nice. So again, what is 3 times negative 2? And notice that the x and the x squared match. So when I multiply x times x squared, I get, and the y squared comes along for the ride. Everybody see that? Next, 3 times 5. X to the 1 times x to the 1. X to the 2. Y to the 2 times y to the 1. Does everybody see how I'm doing it in baby steps? And then last, what is 3 times negative 10? And since the 10 does not have any letters, the x and the y squared come along for the ride. And that is the final answer. How'd you do, Ariel? Got it? Okay. Anybody else have questions about that? Is this easy or difficult?
It's easy right now. It's going to be difficult.
Okay. Believe it or not, that one was about as tough as it's going to get. Believe it or not, that with the multiple variables is about as tough as it gets, okay? All right, next. Number 13. Okay, that's Crystal, right? And just to let Crystal know what's going on here, did y'all see I kind of did it in order? A monomial times a monomial, monomial times a binomial, and then a monomial times a trinomial. And that covers all the monomial options. So now we're going to step it up a notch, okay? Number 13. How about a binomial times a binomial? That's the FOIL. Remember, when they're both bi, you F it up. When they're both binomial, you FOIL it. Have we done the FOIL method in here before? On some problems? Okay, so this might be review then. And what I'd like you to notice here is that we call it the FOIL, but it really comes from the distributive property. Because what we want to do is take the 5x and distribute it. You see the 5x gets to go to each person. And then when the 5x is done, whose turn is it? Then the 2. And then the 2 takes a turn. He goes here and here. So we're going to start with 5x times 3x. Remember my 2 steps? Multiply the coefficients, add the powers. Right, and does everybody see where the x squared comes from? X to the 1 times x to the 1, x to the 2. Next, the 5x now gets to go to the negative 1. And we know 1 times anything is itself, but a positive times a negative makes a negative. So now, has the 5x been used up? And now it's the 2's turn. 2 times 3x. Everybody understand why he's plus and not minus? Positive times a positive, yeah. And last but not least, 2 times negative 1. Negative 2. Now, in most cases, you will need to combine like terms to finish it. 15x squared plus x. And we're done. And that's kind of cool. You start with 2 buys and you end with a try. Anybody have any questions about the FOIL method? Y'all think you need to see another FOIL method? Okay, we'll crank it up a notch then, okay? Let's go to number 23. All right, so what would you call this one? There you go. Binomial times a trinomial. Is it still the distributive property? So this time the x is going to distribute to all 3 terms. And when he's done, who gets to go? Yeah, and then the negative 4 gets to take a turn, okay? Y'all see the game plan? Now let's execute it. What is x times x squared? X cubed. Squared is a power of 2. Cubed is a power of 3. And this, yeah, x to the 3rd is okay. X to the 3rd means x cubed. Yeah, because this x has a power of 1. And when you multiply letters that match, you add their powers, okay? So that's where the 3 comes from. And then x to the 1 times x to the 1, 4x to the 2nd. And you can say 4x to the 2nd, or you can say 4x squared. Either one. And then how about x times 16? And those 3 terms come from the x doing his distributive property, okay? And now whose turn is it? All right, so here, negative 4 times x squared makes negative 4x squared. And I want you to notice that I'm using the stacking technique. Instead of continuing to write it out here on the same line, I'm going to line up my like terms. That's called the stacking technique. If you want to write it all on one line, that's fine. Negative 4 times 4. Negative 16x. Good. Negative 4 times 16. I don't know. That's why God made calculators, okay? 16 times 4. 64. And if you use the stacking technique, it makes it a lot easier to combine your like terms. So we can see the 4x squareds cancel, the 16x's cancel. And we end up with a binomial. That does it? You do it the way that doesn't confuse you then.
We end up with a trinomial again?
Yeah, you want to do one? Yeah. All right, so now let's play the what if game, okay? What if, and you want to do another buy and a try?
I just
Yeah. Let's do one that's more exciting. How about if we had 3x minus 2y, x squared minus 5xy plus 4y squared. How about that with lots of letters? Let's see, who is that? Is that Yesenia? All right, so we've got a binomial times a trinomial, but is it still the distributive property? All right, so let's break it down one baby step at a time. First, 3x times x squared. What did I say? Multiply the coefficients and then add the powers. So now do you see the x squared has a coefficient of 1? And you're multiplying 3 times 1? Then the letters are the same. So we're going to add their powers. 1 and 2 is 3. You see that? 1 down, 5 to go. Next, 3x times negative 5xy. Negative 15 x squared y. Everybody see where the x squared comes from? Look, this guy has an x. Oh, and he's got an x. So since those letters are the same, we're going to add their powers. x1, y1. And then next, 3 times 4. And this time the letters don't match. So you just write them down in alphabetical order. X, y squared. Everybody good? And now we've used up the 3x. Now it's time for negative 2y to take a turn. So again, what is negative 2 times 1? Negative 2. And the letters don't match. X squared y. Everybody see why? It's x squared y. Next, negative 2 times negative 5. Positive 10. Oh, and this time we have letters that match. Y times y. So it's xy squared. We still good? Okay, last time. Negative 2 times 4. Oh, and the letters match. Yeah, y to the third. Or you can say y cubed. And now I got to go through and add any like terms. 3x to the third. Nobody else like him. What about x squared y? Oh, there's one like it. Negative 17 x squared y. Because when you add like terms, the variables are unaffected. Only their coefficients add. Now, do I have any xy squareds? There's an xy squared. Oh, there's an xy squared. How many? 22 xy squares. And then last but not least, and so there we end up with 4 terms. Man, I am trying my best to break it down into small little pieces so you can see it really looks like a big nasty problem, right? But it's just got a lot of little pieces to do. It's almost like doing a 1,000-piece puzzle, right? It looks like a big, huge project, but you just do it one little piece at a time. Yeah. All right, so are y'all ready to crank it up a notch? We're going to go next to problem number 27. And with this problem, we reach the summit. This is as high as we're going to climb. So this time, what do I have? A trinomial times a trinomial. We're not going to do bigger than these, okay? Trinomial times a trinomial. Is it still the distributive property? Yeah, so let's lay it out. First, the a squared is going to go to everybody. That's step number one, a squared distributes. Got it? What would be step number two? Then whose turn would it be? The a. 1, 2. He'll go. And then last. And then the -1 will take a turn, okay? So if you break it down and look at what's going to happen, this is going to be 9 individual steps. 9 little steps, okay? Let's get started. A squared times a squared. How about a squared times 4a? And a squared times -5. Oh, 6 more to go. 3 down, 6 to go. Now who's going to go? A times a squared. Oh, and look, I'm using my stacking technique again. Next, a times 4a plus 4a squared. A times a is a squared. And last, a times -5. -5a. Now, let me do this. Let me erase. No, I'll tell you what. Let's do it in a different color. Bam, bam, bam. Okay, so there's the last step in red. -1 distributes. Got it? So -1 times a squared. And if you want to put, what am I writing it underneath the 5a? -1a squared. Next, -1 times 4a. -1 times -5. Negative times a negative make it a positive. And now the last step, CLT. Combine like terms. I've got a to the 4th. 4 and 1 is 5a to the 3rd. Oh boy. -2a squared, if I did my math right. -9a plus 5. Anybody have any questions about that? Anybody? So if we do another one, you think you can do it? You think? Can I make it up and see? Okay. What's this? So this is going to be my problem. And it's going to be another trinomial times a trinomial. Let's see. Let's do 4a minus 3b plus 2c times 2x plus 3y minus 4z. Everybody ready? Are you doing it on your own? It looks like y'all already started without me. Well, you just couldn't help yourself? You're like, I got to just work this problem. You know what happens when little kids run off in front of their parents, don't you? They get run over by a car. Y'all better be careful. Oh, man. Alyssa is not here. Dang it, Alyssa. David. Jonathan. Kelby. Antonisha. Catherine. Not too bad. Y'all let me know when you're done. We'll do it together. No, not this time, no. No, yeah, I think you're going to end up with 9 terms. All right, I'm starting to go through math withdrawals, so can we do it together? Here we go. 4a times 2x. 4 times 2? Is it xa or ax? 4a times 3y. 4 times 3? Ya or ay? 4a times negative 4z. 4 times negative 4? za or az? Az. Everybody see so far? Next, negative 3b times 2x. Negative 3 times 2? bx or xb? bx. Negative 3 times 3? by or yb? Negative 3 times negative 4? bz or zb? Still good? Okay, here we go. Last time. 2c times 2x. 2c times 3y. 3 times 2? cy? And then 2c times negative 4z. CZ. Unfortunately, there are no like terms, and so that is the answer. Ooh, don't expect to see anything like that on a test. Yeah, that was long and nasty. But do you see how it works? Oh, good. Now we're going to jump over to number 43. And at that point, if you understand 43, I think we're going to be done for the day. And you can spend the rest of the time working on your MyLab math. You do need to be able to recognize these problems and know how they work. So the main thing that you understand is if you have something that's squared, it means multiply by itself. Anything that's squared means multiply by itself. So this is going to end up being x minus 2y times x minus 2y. And is that a binomial times a binomial? And we know if they're both bi, you got to F it up. Right? If they're both binomial, you got to FOIL it. Let's start. X times x, x squared. On the outside, x times negative 2y. And again, if you break it down into the steps, the x has a coefficient of 1, right? So I said multiply the coefficients, and the letters are not the same, so you just put them in alphabetical order. Next, on the inside, same thing, because multiply the coefficients, and the letters are not the same, alphabetical order. Last, negative 2y times negative 2y. 4. Oh, and the letters are the same. Add their powers. Y to the 1 times y to the 1. Y to the 2. Do I need to CLT?
Yes.
How many xy's do I have? 2 terms. When I combine them, I have negative 4 of them. And that is done. And that's how you do it. Anybody have any questions on polynomial multiplication?